Hi all, so welcome back to the lecture series on solving previous year questions of GATE ECE, and we are dealing with the subject analog circuits, and we were solving the questions related to BJTs and MOSFET, right? So let us continue. This is the part 5 of this lecture series. So today's first question is from GATE 2020. So let us start. So the question is, using the incremental low frequency small signal model of MOS device, the Norton equivalent resistance of the following circuit is. So the question is like a MOS amplifier is given here, and we need to find its Norton equivalent resistance. So what we will do is like we have to find the low frequency small signal model, right? So we will just convert this circuit into its small signal equivalent. Okay, so what I will do, I will just draw the pi model of the MOSFET. Okay, so this is an NMOS. So the pi model will be like this. Oh, sorry. Okay, so this is the gate terminal, this is the drain terminal, and this is the source terminal. Okay, so when we see here, the gate terminal is connected to ground. Okay, so this is grounded. The drain is connected to resistance R to VDD, right? So I have a resistance like this to ground, and also it is given that it has a drain to source resistance RDS, right? So we have to draw a resistance RDS across drain and source. RDS, fine. And the source terminal here is the output terminal, or maybe the signal where we are going to apply the signal, right? So we'll call it as say Vs. Okay, so I am applying a voltage Vs here. Okay, so I need to find the Norton equivalent across this. Okay, so I will just redraw this. So say the okay, so let me redraw this. So I'll draw the source first here. Okay, source. Okay, this end, and from here to ground, right? So to gate, it is ground. Okay, and this is plus minus is above. Okay, this is VGS. So VGS is okay, and from source, okay, there is a dependent source like this, VGS, GM-VGS. Okay, and across this there is one resistance like this, that is RDS, and from this node there is a resistance R. Okay, so since this is ground, what I will do is like I can draw like this. Okay, so this is gate, and both gate and this resistance is grounded. Okay, yeah, so this is the equivalent circuit, and I need to find the Norton resistance. I will say like Rn. Okay, so how to find the Norton resistance? So if there is a circuit, to find the Norton resistance, what we will do, just like Thevenin resistance, we'll remove all the source, or we'll replace the sources with its internal resistance. Okay, if it is voltage source, I will short circuit, and if it is a current source, I will open circuit. Okay, and find the equivalent resistance. But thing is like here we have a dependent source here, so GM-VGS dependent source. So we cannot directly find like that. So instead, what we will do, we will apply a voltage here. Okay, so this is VGS. Okay, so this is VGS, and I will apply here one source. Okay, so let it be Vs. Okay, and from the source there is a current Is flowing. So what is Rn now? Rn will be equal to, or I will write here, Rn will be equal to Vs by Is. So I need to find this Vs in terms of Is. Okay, so how we will find? So from the circuit, IS is flowing here, it will reach this node. Okay, there's a current from this GM VGS coming from right end, so there will be flow of current like this, right, through RDS. Okay, I will call it as IDS. Okay, and from here there will be a current flow like this. What will be this current? This will be same as IS, right, because the same current should reach back to this source. So this is again IS, and because of this there will be a voltage drop like this. Okay, IS into RS, sorry, not RS, R. Fine. Okay, so what I will do is, like, I will apply the KCL, Kirchhoff current law, at this node. Okay, say node 1. So KCL at node 1. Okay, what I will get? The current IS is entering, and GM VGS is also entering that node, right? And IDS is leaving, so minus IDS equal to 0. Okay, and from this circuit, VGS is like voltage this one, right? VGS is this. So what is VGS here? VGS is equal to minus VS, right? So I can substitute that here. So IS plus GM into minus VS. Okay, minus IDS is the current across this RDS. So what is IDS? So from the circuit, IDS is the current flowing through RDS, right? So how we can find that? We can find by finding the voltage across this resistance by the resistance. So what is this voltage across this resistance? At this node 1, the voltage is Vs, right? So I can write IDS as the voltage Vs minus the voltage at this node. What is this node voltage? That is a voltage across R, and that is equal to IS into R, right? So I can write as minus R into IS. So that is a voltage across a resistance RDS, and that by RDS is the current IDS. Fine. That equal to 0. Okay, so I'll solve it here. So if I rearrange this, okay, I can club the terms of IS. So it will be 1 from here minus, so plus minus and minus plus R by RDS. Okay, and minus Vs term I can club, that is Vs into GM plus 1 by RDS. Okay, that equal to 0. So from this itself, what will be Vs? So I will bring the Vs term to the RHS. So this will be IS into 1 plus, sorry, I can find the LCM, right, or I can multiply the denominator. So I can write it as like, sorry, RDS plus R by RDS equal to Vs into 1 plus GM RDS, right, by RDS. I can write like this. So this RDS will be cancelled, and what will be Vs by IS? Vs by IS will be equal to RDS plus R by 1 plus GM RDS. Okay, so this will be the effective Norton resistance, Rn. Okay, so from the option it will be option B. Okay, yeah, so this is how we find the Norton resistance. Okay, so now we'll go to the next question. So question 2. Okay, the question 2 is, an enhanced MOSFET of threshold voltage 3 volt is being used in a sample and hold circuit given below. So here a sample and hold circuit is given, and its MOSFET threshold voltage Vt is given as 3 volt. Okay, assume that the substrate of MOS device is connected to minus 10 volt. Okay, if the input voltage V1 lies between plus or minus 10 volt, the minimum and maximum values of Vg required for the proper sampling and holding respectively are. So here V1 is given, that is, it's a signal whose value is lying between plus 10 and minus 10. Okay, so maybe some voltage is coming at V1, and this has to be sampled using this sample and hold circuit. So how it samples? So whenever the voltage Vg is having a magnitude in such a way that Vgs is greater than Vt, then this MOSFET will be on, right? It will be something like this. Okay, so whatever is the V1, that will be sampled and stored in the capacitor C. And holding is like the Vg will be reduced in such a way that the MOSFET will be off, so that voltage will be holded. Okay, so I will get something, some voltage something like this. Okay, so sample and hold will give some sampled signal of the V1. Okay, so question is like, what should be the range of Vg such that it can properly sample the input signal. Okay, so we know to sample, okay, MOSFET should be on, right? Okay, and for that the gate to source voltage VGS should be greater than or equal to Vt, definitely. Okay, so what is VGS? So this is the gate voltage G, and this is the source end. Okay, so this is VGS. So VGS should be greater than Vt, and Vt is equal to, given Vt is 3 volt. Okay, so what is VGS? Vg minus Vs is VGS, and that should be greater than 3, right? So from the circuit, Vg is given as Vg itself, while Vs is the voltage V1, right? This node end voltage is V1, so I can write Vs as V1, so that should be greater than 3. Okay, now we have V1 ranging from plus or minus 10, right? Or so for V1 equal to 10 volt, okay, what should be this equation? So equation 1 will be Vg minus 10, right? V1 is set as 10, so it should be greater than 3 or equal to 3, or Vg should be greater than or equal to 30. Okay, similarly for V1 equal to minus 10, right? Equation 1 I can write as Vg minus 10 should be greater than or equal to 3. Okay, for proper sampling. Okay, so Vg is greater than or equal to 3 minus 10, or Vg should be greater than or equal to minus 7, which means Vg should have a voltage in the range 13 and minus 7 to proper sampling. Okay, to proper sampling it should have a range within 13 and minus 7. For any value apart from this, it will hold or it will switch off. Okay, so definitely it should have this range to proper sample. Okay, so the answer is C. Okay, so now coming to the third question. Okay, so this is the question third. Again, it is from GATE 2020. So it's a regulator based question. So the question is, in the voltage regulator shown below, V1 is an unregulated input at 12. So V1 is sorry, not 12, 15 volt. Assume VBE equal to 0.7 volt, and the base current is negligible for both the BJT. So for both the BJT, VBE is 0.7. So here it is 0.7 volt, and here also 0.7 if it is on. Okay, and the base current is negligible, so which means the base current is 0 almost, right? So IB is approximately equal to 0. That's what it's being asked to assume. Okay, if the regulated output voltage V0 is 9 volt, the value of R2 is, so I need to find the value of R2 while given the voltage across this is 9 volt. Okay, so from the circuit it is clear that if this is 0.7 volt across this, that is VB is 0.7, and there is a Zener which is having 3.3 volt, and it is regulated, right? So what is the voltage across this? It is 3.3 plus 0.7, that is 4 volt. Okay, so across this I have 4 volt, and I need to find R2. So how to find R2? So if there is some current flowing through this as I2, then R2 will be equal to 4 volt, that is voltage across this R2, by the current I2, right? So we just need to find the current I2. So we'll again go to this circuit. So here the voltage is 4 volt, right? 4 volt, and R1 is given, and we know the voltage at this point to the ground is 9 volt. So what is this voltage across R1? The voltage across R1 will be, this point is 4 volt, right? So this should be 5 volt. So 9 minus 4, that equal to 5 volt will be the voltage across R1. Okay, so we know the current I1 through R1. I can say I1 as I1 equal to the voltage across R1, that is 5 volt, by the resistance 1k, right? I will write it's R1 itself. Okay, so that is 5 by 1k. So what is this? This is 5 milliamps. Okay, and so this current is coming from top to bottom till this point, and here the current is 0 ampere. So the entire I1 will flow like this. So which means I2 is equal to I1, right? I2 is equal to I1 because IB is 0. Okay, so I2 is same as 5 milliamps. So I can substitute it here. Okay, so R2 will be equal to 4 by I2 is 5 milli. Okay, yeah, so what will the value? The value will be 0.8 kilo ohm or 800 ohm. Okay, so that is the answer. Here the R2 value is 800. Okay, yeah, okay, so that's all for today. Thank you all.